So, figure it might make a little more sense to use the laptop to record since I have it down here. The audio router is finished. At least the hardware for it is. The software still needs a considerable amount of work. That came out very well. The purple doesn't look quite as awesome over the video, but it's sitting there doing PWM from the Teensy 3 to achieve that effect. So I think the fade is 1 step per 40 milliseconds, so it'll just sit there and pulse. That came out perfectly flush, so that worked out really well. Of the jacks on the back here, those 3 are going to be audio or stereo outputs, and then these 4 over here are going to be stereo inputs. Have to label them yet, but I've got 1 input and 1 output reserved for this dude, or something like it. I think I'm going to wait for the RN4020 to hit my desk, because if it has audio capability, I'd rather use it. But everything fit together okay. The buttons all work, which I'll demonstrate in a minute. I can read all of the parts, and I can route audio. I'm not going to demonstrate the audio down here though, because there's how. So I can show you pictures of my oscope traces, but it just doesn't have the same impact. So it's plugged into USB right now. So you'll notice that it has a USB cord in that power jack there. But the power jack isn't populated, and it doesn't need to be unless you want to run the LEDs. So there's a diode running from the 5-volt supply from this is run through the panels first, then through a diode, and then into the Teensy's VN jack, so that unless it is powered, it can still be powered via USB. There we go. And the USB won't try and power all of those NeoPixel lights, so it's electrically isolated. So I'm going to SSH into it. I have to add carriage returns. Okay, so what you're seeing here is debug code that I've done for the sake of trying to figure out if this or that sensor was working. In this case, the periodicity is from the light sensor, which reads every second. That worked out pretty well. I'm going to blast the light sensor with there we go. So now, ultimately, the software ought to adjust the brightness of the NeoPixel array based on that input, because to not do so, is it actually falling? Yeah, it works. To not do so, you'll understand in a minute, because I'm about to turn them on. This software is running essentially the same stuff as Digitabulum is, ManuvrOS. It's the same code. The software environment, such as you see it, probably only took me 3 hours to put together, and of those 3 hours, about 1.5 of it, half of it was spent porting, because I've never run it on. I had to reintroduce all of the platform-specific code for I2C and all of that nonsense. But the classes to do the buttons, to do the NeoPixel, to do the light sensor, all of that stuff was done within the scope of 3 hours. So that debug output there, there we go. The debug output that you're seeing there is at the top. You see the event manager, which is basically the scheduler core of Manuvr. The subscribers to that core. So you have the scheduler itself, which there's the OS basically has 2 components. It has the event manager and the scheduler. That might get merged into the same thing later, but the scheduler handles low latency, periodic, kind of I need this to happen now kind of thing. The event manager basically just runs stuff in idle time. They both run stuff in idle time, but the event manager doesn't have any kind of delay associated with it. The total events that have run through, each time you see one of those reads, you see no subscriber acknowledged ambient light level. In other words, the class that's dealing with the light sensor broadcast an event saying, hey, my light level changed, and nothing heeded it. So, which is, expected. I've got a lot of software work to do yet, but most of that is going to be UX and integration stuff. All of the core functionality is either already developed in the OS, Manuvr, or I've written it in the past, or someone else wrote it. So basically I just have to tie all that together. But max queue depth, total length. Okay, so the thing with the asterisks there, that cheesy little text mode histogram, is the event identity, how many times it's been executed, total microseconds spent executing it, the average execution time, worst, best, and last. I'm not sure, the RNG buffer empty and the ambient light level are not accurate. I don't know what's going on with that output. But let's go back to there we go. So I can get that output plus the scheduler output if I do that. So the scheduler output shows the schedules that are enabled. Doesn't show any kind of a naming convention, but it does give me the PID. So how many times it's executed. One of those is going to be the light level sensor. And it's probably going to be number 5. I'm guessing that based on how many times it's executed. But I'll show you the actual interesting stuff here. Let me plug this in. The rotary encoder does not yet work, so I haven't dealt with that yet. But if I touch this, so you can see that there's a button, and each one of these procs a separate event. So if I do this again, you can see that there have been events that weren't there before, and that's for the button presses. So as I sit here and press these buttons, it still needs some tuning too. Basically, this is the capacitive touch peripheral on the Teensy 3, more generally the STM line. But that right now I just have it coded to, hey, if your magnitude of read changed by 4 times, then consider it either a touch or release, depending on which direction the magnitude changed. So it's real simple right now, but even being a first attempt, it still works pretty well. Just have to clean it up a little bit, add a little more range check, but all of the buttons respond. The microphone also responds. I don't have a way to demo that here, but once I get the frequency histogram stuff put in, the FFT, then I'll have a way to demo it. But for the moment, I'm just going to turn, watch your eyes. Oh man, that is brighter than God. So this is just the Adafruit NeoPixel demo code that I've morphed into, and it didn't take long to do it, to bake it into Maneuver. I've kind of built it with the idea that I would be porting a lot of stuff over, so it's pretty easy work to do that. I need to attenuate that somehow. Got a static bag down. That's a little more comfortable. Yeah, I got to get the brightness stuff fixed. That's brutal, but it's doing its job. So all of that works pretty well. And then if I do this again, oops, there we go. So you'll notice that there's some of the things I was doing don't have corresponding events yet. That's on the queue to get addressed. This was just a base functionality port to make sure that everything worked okay within the same environment. I didn't crash anything. Most of the goal of putting the software together so quickly was so that I could validate the hardware, so that I knew I would be done inside of this thing. It looks really awesome on the outside, but inside it's kind of a nightmare. It's all right for an engineering one-off. If it becomes a product, I'll not have multiple PCBs like I did. All that stuff is going to be much more tightly integrated, both for space, cost, and power reasons. Both. So with all that being done, I'll show you some of the I2C core. So I can, let's see, let's look at the whole peripheral first. Oops. Okay, so that's device 0. Those are the registers. That's the analog switch, and as you can see, nothing is routed. And those are the 2 digital potentiometers. So if I do this, let's see, I have to set the verbosity to 7. There we go. All right, so I set that verbosity globally. So you see that the output has become, yeah. Let's do this instead. Let's put it back to where it was. I think it was at 4. And let's do a verbosity 7 for I square C adapter. Did that do it? Verbosity query? Yes, it did. Okay. Yes. All right, so now I'm only going to have to, the event manager still takes the maximum verbosity setting. I've got to have a flag for that because that behavior is no longer necessary. But now that I've done that, I should be able to, oh, it didn't print the device list. Sad sauce. Oh, it just refreshed everything. Yeah, so you're seeing all those events now that are coming through as a result of reading those registers. So it's read the entire register set for all of those devices. Otherwise, it wouldn't call it initialized. I'm going to put that back to 4 so that we can actually see what we're doing here. Yeah. There, that's what I was after. So you get that output, but formally that output was followed by all of the dump from every I2C operation required to read those devices. So all of that's working pretty well. I'd say that's not bad for a 2-hour porting job. There's no interrupts on the TNC3 yet. Like, there are interrupts, but they're all managed by their own internal I2C library, which I don't know if I should break that down and use its elements. I'm probably going to end up doing that so that I can have more precise control over the execution timing of things. Because if let's do that again. Let's actually haven't looked closely at this. Looks like I2CQ ready. That's not too bad actually. Oh, never mind. There's an extra digit there. So okay, so 17 milliseconds total for all of the I2C operations that I've been doing on the device for now. Not too bad. There's as I start doing more sophisticated stuff on the CPU, like doing frequency analysis and reading all the ADC pins regularly to know which channels are active, whatever else, I'm gonna want to try and cut that down. Yeah, but that really isn't too bad. Worst case runtime is 262 microseconds. Yeah. Okay, maybe I won't mess with it. It's pretty punchy. The user button release, all of those time values are clearly not correct. But that's just more to that's a bug in the event manager in general. So that I have to make the profiler a little nicer. It came from a C environment, so it's not really it could stand to be adapted a bit more. Brought in, have classes declared, have constructors, destructors, all of that stuff. That the linguistic plushness makes it much easier to not only extend but maintain as well. So that's basically it. I can get back when I've got some the encoder. Encoder doesn't do anything. Encoder doesn't do anything yet, so that has to be debugged. But that should be a quick one. I've got to tie some of these buttons to routing functions so that I can do a channel select here, and then be able to have the 12 input channels show up on this dial, and then rotate to the input channel I want and tap the button again. Could handle it that way, or I could tap, rotate, release. That might make a bit more sense. But I really haven't given too much forethought to how the user experience of the assignments and whatnot goes, because I imagine that the device's greatest strength would be the fact that it's adjustable without sitting in front of it. So I imagine a lot of that stuff would be scripted. But there you have it. I'll get back when I have more.